Hello, children. Let us continue the next part in this chapter. After discussing the distance displacement, speed velocity, we are getting the new term, that is acceleration. Distance displacement, speed velocity. When distance change with respect to time, speed. Displacement change with respect to time, velocity. Though they are similar, but there is a difference in displacement direction. Distance, no direction. Direction is not concerned. In speed, no direction. Velocity, direction. Here, if we change the speed or velocity with respect to time, if the speed changes with respect to time, if the velocity changes with respect to time, that means whenever anything is moving, if its speed changes with respect to time, if its velocity changes with respect to time, generally we should say it is the change in velocity. Whenever the velocity changes, because when anything is moving, the direction, there must be some direction, particular direction, even for small time. That's why we should say the velocity changes with respect to time. We get the word acceleration. So it means acceleration is related to the change in velocity. Acceleration is related to change in velocity. How can we change the velocity? Suppose if I write the velocity of anything is 10 meter per second towards north, let us say. Here the velocity, in this velocity 10 meter per second towards north, this is the magnitude and this is the direction. The velocity can be changed either by changing this only, or by changing this only, or by changing both. Here this part in velocity, this part, that is the magnitude, if we take the magnitude of velocity, it comes the speed. It means the velocity of an object can be changed by changing this value, that is the speed, or by changing only direction, or by changing both. Suppose if you people are riding a vehicle, suppose you are riding bike, that bike is traveling in a particular direction from one place to another, and while riding the bike you are continuously seeing the speedometer. In the speedometer the needle will move from this part, from A to B. You are seeing that the needle of speedometer shows 60 continuously. It is not changing. Then you will say the object is in uniform motion because the speed is constant. It is constant, uniform motion. In that, the speed is constant, direction is also constant. So we say the velocity is constant. Velocity is not changing. Velocity constant. If in the second case, if we see that the speedometer continuously and the value, the pointer, in the beginning it was at 0. As the vehicle is moving along this line, the pointer continuously moves towards right. Suppose it is 20, 40, 60. In this way, the pointer continuously moves. So in the beginning, its speed was 20, then it become 40, then it become 60, then it become 80. So continuously the speed is increasing, but the direction is constant, moving along the same straight line. So the speed is changing, speed changes, direction constant, direction constant. By combining the speed and the direction, we get the velocity. We get velocity because velocity is represented with the speed, magnitude, and the direction. Here, the magnitude is changing and the direction is constant, so we say the velocity is changing. So, since the velocity is changing, whenever the velocity is changing, we say what is produced? Acceleration is produced. The velocity is to be changed. For that, you can change the magnitude or change the direction. Suppose, changing the direction, I give an example. You are traveling in a vehicle and the vehicle is traveling in this direction. Suppose the speed is 40 km per hour. It is constant from A to B. From A to B. From the point B, it turns towards this side, to point C. And here also its speed is 40 km per hour. Now you see, in this direction the speed is 40 km per hour, and changing the direction the speed is same. Here if you see, the speed is 40 km per hour, that is constant. But what is changing? Direction is changing. Direction changes. So by combining these two, speed and direction, that is magnitude and direction, so we get the velocity. Here you see, the speed is constant 40 km per hour, but the direction is changing. When the speed constant, direction changes, again we can say the velocity is changing. So in this also, the velocity is changed. You should not say velocity is constant. It is direction is changing. Magnitude is constant. Magnitude is constant. By changing the direction, here also the velocity is changed. So here also what is produced? Acceleration produced. So acceleration is simply, it is change in velocity per unit time. Change in velocity per unit time. Unit time. So it is represented by the symbol A, small letter A we use. So the acceleration is, it is change in velocity upon time. That is the acceleration. Otherwise we can define like this also, it is rate of change of velocity. Rate of change of velocity. Rate of change of velocity means velocity changes with respect to time. That is the formula. Change in velocity, the velocity changes from one value into another. Velocity changes from one value into another. Suppose a car is traveling along a straight line from A to B. In this case, the velocity is continuously changing. Suppose it is starting from rest. In the beginning, if it is at rest, the velocity is definitely zero. Is zero. As it is continuously moving, after some time it reaches the point and there must be some velocity. There must be some velocity. In between this, the velocity continuously changing. It may increase or decreases. And for this we take, here we are going to measure the velocity at this point and this point. In the beginning, we are having the velocity that we call initial velocity. Initial velocity. The initial velocity is given by the symbol u. And at the point where we are going to find out the velocity at after some time, that is final velocity. Final velocity. So final velocity is given by the symbol v. Now how much is the change in velocity? That is final minus initial. That is the change in velocity. Change in velocity. So change in velocity is equal to v minus u. That is final minus initial. Then it can be applied in the formula. So the acceleration is equal to change in velocity minus change in velocity upon the time taken. In how much time that velocity is changed, that is t. Now this is the formula. That is acceleration is change in velocity upon time. Also it is defined as rate of change in velocity, and it is symbolized, it is a equal to v minus u upon t. V final velocity, u initial velocity upon in how much time that change in velocity taken place. And one more thing, here the velocity is also a physical quantity. It has the unit, that is change in velocity is also giving some velocity, so it is meter per second upon time is second. So the unit is meter per second square. This is the SI unit of acceleration. This is the SI unit of acceleration. So this is the basic concept of the acceleration. Next we will see in the next session.